So, for those of you that haven't used ZBrush, I'm sorry. Because it's going to make this whole process a little bit more difficult. Let's actually start with a different model. Okay, see, this one has better topology to demonstrate what we want to see. Geometry, let's see. Okay, there, now it's editable. And let's see if we can. No, it doesn't like that. We can't reconstruct it. Anyway, so let's say this was the model that you got and you wanted to detail it, and we're gonna mouse sculpt. Not a good idea. What you need to do is actually go into morph targets and store your morph target. Now you can do your stuff. If you switch, it'll go back to the original. So right now, the original state of the model is stored there. If we subdivide this, we can't switch back, but there is a morph target stored at the lowest resolution. So that means we can add all kinds of fun details here. And if we look down here at the base level, we'll see that the base model has changed, but the original mesh hasn't. It's stored in the morph target. So if we use the multi-map exporter under Z plugins, I don't even know if this has UVs. Hold on. Okay, good. Okay, multi-map exporter is what you need to do to export things. And let me see if I can get these settings right. So you get export options. You're going to want to turn on this switch morph target. What this means is that when you start baking, it's going to use what's stored in the morph target to do the bake instead of this model here. Then you also want to, you want a displacement map and a normal. You're going to generate the map from the lowest level. And we want 32-bit EXRs. This means you're going to have a signed value, which means that in that like if you sculpted it and you displaced it 1.5 units, that's the value that's going to be stored in the EXR. If you write out to a format like TIFF, TIFF is stored in 16-bit integer. It still has high precision, but you need to know what the scale is, and so it will tell you. Instead, we bypass all that. We use EXRs. It just stores the absolute displacement value. We like that. It makes life easier. Smooth UVs likely needs to be turned on because when you render with RenderMan, it subdivides the UVs. I don't know that ZBrush still does the subdivision on the UVs correctly. I had a conversation with them like, I don't know, like 15 years ago talking about this, because at that point they were doing the same thing that Maya was doing, but Maya was not doing the same thing that RenderMan was doing. I don't know the state of it, and that's why this is one option for doing it. I will show you another option. Okay, so you probably want to smooth the UVs. See, if you're doing 16-bit, you need to get this scale, and it'll tell you the range of the file. Let's see, we also need to go onto the file names, and we want to tell it that we want UDIMs. So we're going to click on here until it says UDIM. And then this stuff is fine. We'll hit OK, but you want to make sure this says UDIM. Otherwise, it's going to use one of the other things. See this UUVV? Mudbox didn't use the UDIM format. UDIM format was popularized by Weta with Mari. And it's a lot easier to work with than the other formats. Okay, so we set that. Okay. And you can export other things, but let's turn on normal. Let's turn on displacements. And we've got the file names, got the subdivision level. I think I have everything set correctly.
Do you have to change normal map in all settings? Like down below?
I think the default ones are OpenGL. Let me see.
And further down.
Let's see, tangent. I don't know if we need that on or not. Probably. Let's see. Like I say, usually if I was doing this, I would consult the guide because every single time I tried to do it from memory, it was usually wrong. So, you can also save your presets. Do that, it'll make your life easier. And let's create all the maps. All right, it's exported the maps. Remember, so when you're trying to figure out how much resolution you need, just remember how many pixels are in a map. Like a 1K map has 1,000,000 points in it, right? A 4K map has 16 million points. If the model you're sculpting has 4 million points, do you need a 16 million point map to hold the detail? This is kind of a trick question. Maybe, maybe not. It depends on how you're distributing your data in your UVs. Like if you have things well distributed, no, you probably don't need a 4K map to contain the details because you don't have that much detail in your model. But if you have things really poorly distributed, you might need a higher res map. So you'll just need to look and see how it all works out. Okay, documents. Let's see what happened. Yeah, I don't know.
What about the displacement?
Yeah, so let's see what's wrong here. Okay, we got a 2K map. Created all the maps. Let's see. So I think we actually need to. No, I don't remember. Let's see. This is why I don't like using the multi-map exporter. Let's try increasing this. Oh, and then I just recommend look at the documentation. Oh, can't. Let's see. Yeah, so this is why I don't like it. So let me talk about my preferred way to deal with this problem in production. Just look at the documentation. It works. I don't know what I've done wrong, but it works fine. So let me show you the alternative. And this is the process that I came up with for dealing with ZBrush in production, because you don't want to change the model. You don't want to deal with the idiosyncrasies of ZBrush sometimes because it gets to be a little bit annoying. So the process I came up with is reliant upon Houdini. And this was inspired by a workflow from Disney, actually. So it's not entirely my idea, but thanks, Disney. So the way Disney likes to do it, when you're doing sculpting with Paint 3D, you just export the model at a high res and you sculpt it. So for me, the workflow is like this. You take your model, you subdivide it to the level that you need to capture the details you want. Then you save out your model onto disk. So now you have, like generally I would keep a one that I'll sculpt and one that I won't sculpt, because I'm not necessarily doing this in the same day and I want to make sure that everything is there and ready. So I've got the model that I want to sculpt. It's high res. I've done all the subdivisions here. So now I know what the UVs are being smoothed like, how the subdivision is happening, and I can control the resolution and such. And then what we do is we load back in a sculpted model. Let's turn on lighting here. Okay, so we load back in a sculpted model where we've sculpted all the details we want. And then what we do in Houdini is we actually compute the difference between the original model and your sculpted model, and we store that in a map. Basically the same thing as ZBrush, but here we have control over UVs, subdivision level, subdivision algorithm, and so on and so forth. And you could even do fancy things like subdividing one region more than another, or using a different algorithm altogether. And then you're going to load that in, and you're going to compute the difference between these models using an attribute wrangle node. And, all right, who's done linear algebra? Okay, so let's look at this. I've taken the positions from my undisplaced model and from my displaced model, and I've subtracted them. So now I've got a difference between the models. Now, that difference is a vector. You can do displacements with vectors. It can be pretty cool. You can do lots of fun stuff with it, but a lot of times we don't want the overhead of having to have a 3-channel map when a 1-channel map will do. Because these are floating point, high precision maps. They're a lot bigger than just a regular texture map. So we have a vector. Now we want this relative to the normal. So how do we, I mean, you're looking on here, so you can probably guess, but how do we get one vector relative to another vector?
Relative in what way?
How do you project one vector onto another?
Dot product?
Right. So the dot product projects a vector onto another vector. And so if you have a vector that's pointing like this, like let's say when you did your sculpt in ZBrush, you push things around a little bit so they're not exactly normal from the original surface. So when you subtract them, you're going to get a vector that might be slightly off. And what we're going to do is we're going to do a dot product of that vector with the normal on the surface, and that's going to project this vector onto this vector. So now we have a floating point value that's relative to the normal. So that's what I've done here, and then I've scaled it up by 100 so we can see it in the viewport. So see, I've now embodied all of my detail here. I scaled it up by 100 because if it was at 0, if it was at 1, we can't really see it. And we're not using the color anyway, so this is just for visualization purposes. So we've stored all the details, all the bumps, lumps, wrinkles, so on and so forth. And now, before Copernicus, the new COPS operators in Houdini, you had to like do some other like funny business with volumes and stuff to get the data. But now with Copernicus, you can put down a COPNet and you can do a SOP import. So we're importing the geometry. See, we've got null 1, and up here we've got null 1. So we import the geometry. We plug the geometry into this rasterized setup. We tell it that we're using the UVs. We're rasterizing in UV space. And then in this SOP here, or COP, we have rasterized geo, and we say that we want to get the displacement attribute from that mesh. So in here in the attribute wrangle node, we put the data in f@displace. displace. If we look at the geometry spreadsheet, we've got displacement data here. So this represents our signed displacement value. It goes in and it goes out. In our COPNet, We can rasterize that channel, and then we can run it through the height to normal function. It doesn't really have any particular parameters, and then you can save out your file here. You can also save out the height channel too. So when we're all done, we end up with, let's see, a normal map that does have data in it, even if you can't quite tell because it's quite subtle. Like, see, there's data. We have a height map as well. It's also equally like dim. You can barely see it because the values are stored in floating point. I didn't displace anything very far, and so all these values are going to be really tiny. I rendered this out with the apprentice version, and so that's why I've got a watermark. Then when I go into my renderer, in this case we've got Blender, then I can load in my sculpted detail, do the normal map. I can add to that any detail I've done in Substance Painter. I normalize it so it's 0 to 1, and I can plug it into my material. And then we get the sculpted details without having to deal with ZBrush's system. This is also nice because you can do the same thing. It doesn't matter where you do your displacement. You can do it in Blender, you can do it in ZBrush, you could do it wherever you please. But Houdini's the one doing the map generation instead of ZBrush. Okay. Remember that when you're doing your skin, the subsurface is important. If we don't have any subsurface, it's going to look like concrete, and we don't want concrete. And my map is only 1K. It's not quite high enough res to capture everything, but it's okay. So when you're working with your subsurface, the same goes in RenderMan as in Blender. It's like the scale is one of the important parts because this is determining like how far the light bleeds through the surface. Okay. Questions?
What's the difference between this and baking in Substance Painter? Like taking the high poly mesh underneath in Substance Painter and just baking?
So Substance Painter is fine unless you have things that are close to each other. Like let's say your nose is close to the cheek here. Substance Painter is going to use ray tracing to compute the difference. We can do that in Houdini as well. But if we're not reliant upon ray tracing, we don't have to worry about overlaps. Whereas in Substance, you do have to worry about overlaps. So yes, you can totally capture your maps in Substance Painter. It's a great way to work. I've done it myself. But if you have any tricky geometry or lots of geometry that's close to each other, wrinkles, folds in clothing, armpits and things like that, that's where it can be troublesome sometimes to do the ray tracing method, and this prevents that need. Okay, any questions?
Can you send us the big scope in that reframe?
Sure.
I took a picture of it. I can send it.
Okay, now I want to do a demo on detail sculpting. I guess we can do it on the other machine. Let me turn off the recording.